We are live. Okay, so the first thing you want to do definitely is make sure you read through here and understand the units and what they're telling you here. Also, just before you can get into this, please keep in mind there's a difference between, like for instance in this case, the weight of the bird and the rate of change of the weight of the bird. They're different values, they're different quantities. One is what it actually is, one is how fast it's changing. Okay, I think that's a lot of confusion sometimes for students. But this whole thing is about the weight of a bird, and they're telling you at time 0 it weighs 20 grams. Okay, the reason why they're giving you that point, foreshadow-wise, is that eventually they're going to ask you to solve for B. They're going to ask you to solve the differential equation, and they can't do that unless they give you a point on the graph. Okay, that's the difference between what we were just doing with the fake testing I gave you. Okay, where we just left plus C in there, versus when they give you a point, you got to find plus C. Okay, so that's, I told you, that's usually question C, and that's what they're going to ask there. Use separation of variables. That's a fancy way of saying separate both sides, right? That's all we ever do, and then integrate both sides. Okay, so we're going to get there. And they also tell me the derivative of the weight is right there. Now, most of the time we see derivatives depending upon the independent variable, like t in this case, right? Usually say dB dt equals like something with t's in it. This just has a b in it. It doesn't matter. The weight tells you what the rate of change is going to be. So when they ask you, then they write this out again here for some reason, but that's the same thing they set up there in the sentence. Okay, when they ask you, is the bird gaining weight faster when it weighs 40 grams or 70 grams, what are they asking you to compare? The rates. They want to know the dB dt's when the weights are 40 or 70. Okay? What? Go ahead, man. Okay? So, luckily I know what dB dt is, and I know it depends on B, so I can plug them in. And the way you note that, you can either write dB dt at t equals 40, okay? Or you can write that in words. When t equals 40, dB dt equals. Okay? The little bar thing is the same thing as like function notation. Everybody feel comfortable with that? You don't have to use it. You can write it out in words, but you got to denote that we're looking at it when t is 40, specifically somehow.
Should you do plus 20?
What do you mean plus 20?
Because that times 0.
No. 20 is only like the weight of the bird at 0, right? We don't care about that. We care about how fast it's changing. That 20 has nothing to do with that. Okay, it's a good question. But you plug 20 in, what do you get? 80 over 5? What is that, 16? 16. Oh, I plugged in 40. God dang it. So what did you get, 60 over 5? 12? Great. Grams per what, day? Okay, and then we got to find dB dt when t is 70. What's that, 30 over 5? 6? Well, when is the weight growing faster? 40. At 40. Just write a little sentence. The bird is gaining weight faster at t equals 40 because dB dt when t is 40 is greater than dB dt when t is whatever, 70. Simple enough? Okay. Look, mathematically we plugged in two numbers and subtracted and divided by 5. Okay, pretty simple. This is all about, do you understand what they're giving you? Like, do you understand like the vocabulary basically here? Okay. B says find d squared v over dt squared. That's the second derivative of b with respect to t twice. So, if we had b, we'd have to drive it once and then drive it again. But we already know dB dt, so we just drive that one time. The derivative of b twice with respect to t twice is, something you can do here, guys, just to make this a little simpler for us, since we have to drive this, is distribute that 1/5. That'll work out. The reason they didn't do that is because it's easier to integrate it if they leave it the way they have it. It's easier to do part C if they leave it the way they gave it to you. Okay? It doesn't really matter, though, at this point. So you should be able to derive either one of those, hopefully. The second one is easier to derive. The derivative of that is negative 1/5 dB dt. Common mistake is just to write negative 1/5 times 1, right? Because the derivative of b looks like it should be 1. But the derivative of b is only 1 if we're deriving with respect to b, yeah. The derivative of something is only 1 if you're deriving with respect to that thing. Okay? So it's really negative 1/5 dB dt, which you never leave a dB dt or derivative in there if you know what it equals. Plug it in. We know that dB dt is that. Is that okay? And that's totally fine to leave it like that. I'm going to simplify it a little more. You don't really have to. I'm just showing you variations of this. That's that right there. Is that okay? And if you really felt like going crazy, you could distribute the negative 1 over 25, and that would give you negative 4 plus 1 over 25b. Sound good? Again, any one of those is fine after you plug in what dB dt is. Okay? So that's what they did. And then they said, use the second derivative to explain why the graph of b cannot be the one provided here on the side. Did we talk about this yesterday at all? Maybe it was 6th period. I can't remember. Okay. Why are they asking us to use the second derivative? What do they want us to investigate? Concavity. Yeah, the concave up versus concave down. Okay. So all you got to do is see this graph over here is initially concave up and then concave down after a certain period of time. Right? Later on, man. Just take a point you know, right? Like, for instance, like we know it's 0, the bird's weight is 20, right? Drop that into the second derivative and see what it is. Just take a few points. We got to find a place where the concavity of the graph is not the same as what it's supposed to be. Does that make sense? That's what they want us to find. Okay? They're not going to make it crazy difficult. They're not going to make you check 1,000 different things. Take the point they gave you. All right? If you plug 20 into your second derivative, do you get a positive or negative number? Negative, right? And remember, we're plugging in 20 for b, but at that time, the time is really 0. So what that tells us is at time 0, the graph should be concave down because the second derivative is negative. Okay? But the graph they gave me at time 0 happens to be concave up. That's all we're going to say. Okay? So we can write it out in words. Since d squared b dt squared when b equals 20, that's what we're doing, right? Equals, and you can find what you can write less than 0 really because it's negative. We can write it out. It's what is it? Negative 80 over 25, which you can reduce. But in these free response questions, you don't really need to worry about reducing. What are the units on there, by the way? Grams. D squared because we derived it, so we got another days down there. Okay. The graph of b should be negative when b equals 20 grams. Okay? So not negative. God dang it. Concave down. When b equals 20 grams. Sound good? But the graph that they gave us is not concave down at when b is 20 grams. That's all we're going to say. The provided graph is not, my handwriting is awful, is not, that looks ridiculous. Is not concave down, yes, when b equals 20. The provided graph is not concave down. Okay? And look, I'm going to finish this question. I know the bell just rang, but just so we have a nice video of it, okay? And part C says, solve the differential equation, which always means separate and integrate in a Calculus AB course. So, we got our dB dt here. We're going to separate that looking like this. This is part C. It is 1/5 dt. When you integrate that, folks, you can leave. It's okay. I'll just talk to myself. Yo, you get that integral, okay? You can do a u sub if you want. You can let u be 100 minus b, but you're going to end up with that. Later on, you do. So we're going to divide by a negative. Negative 1/5 t. Oh, well, minus c. I want to find c, right? We should have found c in the first step, usually is what I do. But when I plug in 20 for b, I plug in 0 for t, and we get that. You plug in 0 for t, 20 for b, and you get that. Is that okay? Which means c is really negative ln of 80. Okay. So essentially what happens here, again, look, so this is really this, right? So the equation we have becomes ln, the absolute value of 100 minus b, equals negative 1/5t plus the ln of 80. Simple enough. And remember I told you with absolute value, it's either going to be positive or negative, like you can't cross through. Yeah, when we plug 20 in, the thing is positive. So the absolute value here is not really doing anything at this point. Now we raise to the e. Okay. And if you remember with addition and the exponent, like a plus up there is really the same thing as multiplying, right? And e to the ln of 80 is just 80. So it's 80e to the negative 1/5t. You got 100 minus b. And if you solve that for b, you get that b is 100 minus e to the negative 1/5t.
Nice.
What's up, Flick?
Good. You want to put this down underneath and you're leave on top.
Okay. Now we're going to leave it just like that.
You're okay?
Let's see, what's the question ask
What's
us
the value
here?
of E?
I don't know.
2.71.
It's just find a particular solution. That's it. We did it. That's the answer. Ta-da. What's up?
What's the definition? The limit as?
Particular solutions when you plug in and find what C is. Yeah. A general solution.
That's not right.